So this sample video is to show how to do a limiting reactant problem. Now, in this question, it describes the chemical reaction. Nitrogen gas can be prepared by passing gaseous ammonia over solid copper 2 oxide at high temperatures. The other products of the reaction are solid copper and water vapor. How many grams of nitrogen are formed when 18.1 grams of ammonia is reacted with 90.4 grams of copper 2 oxide? Also, which reactant is limiting? Now, as with all stoichiometry problems, the very first step is you must provide a balanced chemical equation. So we're going to balance this very quickly. We have nitrogen, hydrogen, copper, and oxygen. Oxygen and everything is found at only twice, so that the order does not really matter. We have 1 nitrogen on the left, 2 on the right, 3 hydrogens on the left, 2 on the right, 1 copper on each side, 1 oxygen on the left, and 1 on the right. So for nitrogens, we need 2 on the left, so we put a 2 in front of the ammonia. That also gives us 6 hydrogens. On the right, we put a 3 in front of the water, which gives us 6 hydrogens, but also 3 oxygens. So we now balance the oxygen by putting a 3 in front of the copper 2 oxide. That also gives us 3 copper. And then finally, we put a 3 in front of the copper on the right, and now it is balanced. Now, for this problem, with all limiting reactant questions, there are 2 starting points and only 1 endpoint. So the easiest way to do a limiting reactant question is to simply do it twice, as 2 separate mass-to-mass stoichiometry problems. And then, whichever one gives us the lower number is the actual correct answer. So for the first one, we're going to be going from 18.1 grams of ammonia, and we're going to the same endpoint, how many grams of nitrogen. When I write out my equalities, first and foremost, I use my mole ratio. Starting point, NH3. So I find NH3, here it is, coefficients of 2. So I have 2 moles of ammonia. And now the endpoint is N2, coefficient in front of that is a 1. So I put 1 mole of ammonia. Now I look at the units of my starting point and end point to find what additional equalities are needed. The fact that that is grams means that I need the molar mass of ammonia, NH3. So 1 mole of NH3 is equal to 17.04 grams of NH3. For that, the way I got 17.04 is I have 1 nitrogen at 14.01, and then 3 hydrogens at 1.01. Multiply that by 3, that's 3.03, plus the 14 gives me 17.04 grams. Now I also need, since that is grams there, I need the molar mass of nitrogen. Well, again, each nitrogen is 14.01. 2 of them equals 28.02. And again, it's molar mass, so that's 1 mole of nitrogen equals that. So I set up my grid, 18.1 grams of ammonia. I put grams of ammonia on top. I want grams of ammonia on the bottom, right there. So I have the 17.04 grams of ammonia for every 1 mole of ammonia. Cross that out. Another vertical line. Moles of ammonia on top. I want moles of ammonia down here. Can't use this one, so I use this one. I put 2 moles of ammonia, and it's equal to 1 mole of nitrogen. I cross that one out. And now I have one more vertical line. I have moles of nitrogen here, so I need moles of nitrogen there. I'm going to use these right here. and that's 1 mole of nitrogen is equal to 28.02 grams of nitrogen. I make sure everything cancels out. Grams of ammonia, grams of ammonia, moles of ammonia, moles of ammonia, moles of nitrogen, moles of nitrogen. Leaves me with grams of nitrogen, which is exactly where I want to end up. So, on my handy-dandy calculator, I simply go 18.1 divided by 17.04 divided by 2 times 28.02 equals, and since there are 3 significant figures here, I round this off to 3 significant figures, so 14.88 becomes 14.9. So that's 14.9 grams of nitrogen. Now, I need to do the same thing again, but this time I have a different starting point. I'm going to have 90.4 grams of copper 2 oxide. So I go 90.4 grams of copper 2 oxide. And again, the question is how many grams of ammonia? The mole ratio now is copper 2 oxide, coefficient is a 3. So I have 3 moles of copper 2 oxide, so 3 there, equals, again for nitrogen, coefficient is 1. That's 1 mole of nitrogen. I need, since this is grams here, I need the molar mass of copper oxide. Copper 2 oxide, copper is 63.55. Oxygen is 16. So 63.55 plus 16 equals 79.55. So 1 mole of copper oxide equals 79.55 grams of copper oxide. And for the final equality, I'm going to use the same one here since it's the molar mass. That's grams. I need the molar mass of of nitrogen, which is still 28.02 grams. Now I go ahead and set up my final grid. I put, as always, the starting point in the top left-hand cell. I have grams of copper 2 oxide there, so I need grams of copper oxide there. So I look for it, and it's right there. So I put 79.55 grams copper 2 oxide, and it's equal to 1 mole of copper 2 oxide. Cross that out. I now have moles of copper 2 oxide on top. I want moles of copper 2 oxide on the bottom. I use those right there since only one's not canceled out. So that's 3 moles of copper 2 oxide, and it's equal to 1 mole of a nitrogen. I cross that out. I have one more equality, so one more vertical line. I have moles of nitrogen there. I need moles of nitrogen there. So I take that. I put the 1 mole of nitrogen on the bottom and 28.02 grams of nitrogen on top, since that is what it's equal to. Canceling out, I have grams of copper 2 oxide, grams of copper 2 oxide. Moles of copper 2 oxide, moles of copper 2 oxide. Moles of nitrogen, and I'm left with grams of nitrogen, which again matches the units of my endpoint. So now, again, I use my calculator. I have, starting off, 90.4. So I go 90.4. It's on the bottom, so I say divided by 79.55. That's on the bottom, so divided by 3. That's on the top, so I go times 28.02 equals, and I get, again, 3 significant figures here in the starting point. So I take this and round it off after the 3rd digit, so that's 10.6 grams of nitrogen. Now, in a limiting reactant question, you always choose the smaller of the 2 amounts. What this basically means is that once you get to 10.6 grams of nitrogen, the reaction stops, since you've used up all the 90.4 grams of copper 2 oxide. Even though there's more ammonia, and you theoretically could make as many as 14.6 grams of nitrogen, once you get to 10.6, the reaction stops. So that is how many grams of nitrogen are made. And since the starting point that gave you that amount, the 90.4 grams of copper 2 oxide, that is the limiting reactant. So we would say copper 2 oxide is the limiting reactant. And there are 2 answers. Thank you.